So as we've seen so far, our program starts from the first line and it continues to execute every time it's just going to the next line. So what if we want to basically break this pattern and basically have some diversion in this straight line execution? So that's why we have jumps or branches. So there is, in general, there's two type of branches. It's unconditional and conditional. So first, let's look at unconditional jumps. So the way you do that is that first you define a label. So for example, you have here main, let's say. So when you have this label, this memory location that this code exists on gonna be marked. So as we said, each line of code, it's gonna be in one memory location, so one address. So when you have these labels, these locations gonna be marked in compile time, and then you can have the syntax J as for jump, and then your label. So when you have this one, once the compiler or once the processor gets to this location in your code, it's gonna go to that label. So once you get here, it's gonna like initialize this T0, and then it's gonna get here. After this line never gonna get executed. So it's gonna just jump here and then continue to run. So that's basically the unconditional jump. What about conditional jumps? So in other program that we have, like for example Java, we have this kind of this syntax as if. You have switches and you have so many different, like for example loops, that basically breaks that pattern of a straight line and like the straight line execution. So we are using if here, and some condition is being checked. So in C, for example, if this is true, this line of code gonna be executed. If you had an else, if this wasn't true, we would skip here and we would go to else. So how do we do that in MIPS is that we have a series of instructions that are checking some kind of condition, and then we give it a label. So if that condition is true, we are going to that label. If the condition is not true, we are going to a next line. So I'm gonna show you more examples. So let's look at this one. So this is one basically statement that we have, and it's BEQ, as in branch equal. So this gonna check if S0 and S1 are equal, they are both the same number in memory, they have the same value, it's gonna jump to the label. So whatever label that you put. If this is false, so that means they are not equal, it's just gonna go to the next line. So it's very simple instruction, right? So we don't have like multiple for like ifs and then else ifs and then like else or switches. So all of the basically conditions that we have in other languages, it could be converted to this, and we're gonna see how. So this is the first one, basically branch equal, and always the condition that we are checking is to be true. So for example, we have branch not equal. This one also, even like there is negation here, but this one also is checked that this condition that is saying is true. So it's checking that if these two are not equal, then it's going to jump to this one. So we have a different one. So we have branch less than. So if S0 is less than S1, then jump to this label. If it's not, you just go to the next line. So all of them, they work the same, just the conditions are different. And then we have branch greater than. So if this one is less than that. So if this one is greater than that, so always the first. If S0 is greater than S1, then go to the label. If not, you go to the next line. We have branch less or equal. So if S0 is less or equal than S1, jump to the label. Otherwise, go to the next line. We have branch greater or equal. So if S0 is greater or equal than S1, then jump to the label. Otherwise, go to the next line. So let's now try to translate one simple if statement. Let's say we have x is not equal to y, and then we are doing some operation, adding x plus some and saving it to this. So if we convert this one as is, like exactly as this, what's gonna happen? we have a not equal, so I'm gonna put branch not equal, and then S0 and S1 is X and Y, and our branch or our label that we have is if. So I'm gonna put the if here. And then our statement. So I'm translating this, right, as is. The statement is sum is equal to sum plus 1. How do I do that? I could do a add, and we have this already in 2 registers. So sum is S2, X is S0. So I have S2 and S0 here, and the result gonna be in S2. So I have add S2, S2, S0. So that's basically exactly as this one. So what is the problem now? The problem is that, if this is true, let's say the branch is not equal. So let's say X and Y are not equal. If this is true, we are jumping to if, and we are running this statement. Perfect. So as what we expected. So if this is true, we are running this one. And here also, if this is true, if they are not equal, we are going to if, and that's if, and we are running this. But what about if it's not true? If it's not true, we're gonna go to the next line. So where is the next line? It's actually right here. So then we're gonna run the same thing again. So do you see the issue actually what is going on? So if it's true or false in both cases, we're gonna run this statement. So that's not what we want. So how do we do that? We have to basically change. So we have to change this condition if we want to have it in this format. So if we had, instead of x is not equal to y, so what originally we had x is equal to y. So the negation of that. Then we could translate it in this way. We say if they are equal, go to the label, right? So if x and y are equal, so that's the negative of the original statement. So if it wasn't the case, kind of. So if it wasn't what we wanted, go to the label. And we're gonna put the label after our statement. But then if it was false, as in if they were equal, that means the original statement is true, so they're not equal. Then it's gonna go to the next line and it's gonna run this statement. So that's what originally we wanted. So we have instead now BEQ. So if they are not equal, or sorry, if they are equal, which is the negative of the original statement, we are skipping this. Exactly what's supposed to happen. And if they are equal, sorry, they are not equal, this is going to be false, and we are going to the next statement, and we run this. That's exactly what we want. So one way to do this, to make this a bit simpler, so it's not just words and you're like thinking kind of like imagining it in your head, like you can put it down on the paper if you do some flowcharts. So we can make a flowchart for this one. In general, in the flowcharts, usually we have boxes as a statement, and then we have kind of this shape for conditions. So we have arrows if it's true or false. So yes for true, no for false. And let me go back. Yeah. So we can basically draw these and try to see how our code is flowing. So this is the flow chart for what we have here. It's branch equal. So if these two are equal, is yes, which is we are exiting from that statement. So we are going to a label which is like after. And if they are not equal, we are going to this statement that we originally had. So when you want to translate, you can basically draw the original one and then try to change the conditions to make it as what is expected to run. So here we have again the original flow chart. So if it was x is not equal to y, so this is what we have the condition here. If it's yes, we are doing the sum, and that is our original statement here. So if that's yes, and if it's a no, we are going out. So what we have here, when we changed it, we changed the yes or no, basically flip those, but also we change our statement, right? So these are equal. They're equally doing the same thing. And but we see that if we are translating this one to MIPS, like this logic, it's actually gonna work perfectly with our statements that we have. And the reason is that this straight line here is that what is being ran or what is being executed. But also the straight line is where we are going to the next statement, and our branches that we have are going to the next statement if it's false. So always they go to the next statement if this condition that we have was false. So that means if you keep all your no's or all your false in the straight line in the main line of execution, you can, I think, almost translate it as is, like without even like checking. But it's always good to kind of double check your work. So basically, if I want to summarize how to do this, you first draw the original as if you have like a C code or Java. So you first draw the original flowchart, and then you check whenever you have a yes or true in your main line of execution, you kind of want to switch that to a no. And I mean, of course, you cannot just switch it to no. You have to flip the true and false. So the no would go here, the yes would come here. So basically, you're flipping those, right? And the way to flip it is basically to negate your statement. So if you have x is not equal to y, it's gonna become, if you negate that, you will have x is equal to y.